right, so now we want to talk about what causes uplift. And as you can see, there are four major causes. And the first one is that regions with thicker crust are going to be topographically higher. And now you can try this very easily by just having different sized ice cubes. So in your freezer compartment, you should be able to, by pouring different amounts of water into the holes in your ice cube tray, you should be able to make normal sized ice cubes. But then if you pour a little bit of water into the ice cube tray, you could make one that's only about that big, and then you could make one that's like this. All right, then very carefully take out those ice cubes and then put them into a tray of water. And what you're going to find is the same proportion of the ice cube is going to stick up out of the water. So roughly speaking, about 9/10 of an ice cube is going to be under the water, and about 1/10 is going to be above the water. And then 9/10 of this ice cube is going to be under the water, and then 9/10 of this ice cube is going to be under the water. But look at the amount that's sticking up out of the water, and you'll notice that this one sticks up out of the water more than this one, and then this one sticks up more out of the water than that one does. So I really do want you to try that to verify that that's true. So that the thicker parts of a continent are going to be topographically higher than the thinner parts. So this means that if you've got a mountain and the mountain sticks up like this, then it actually has a root that is actually much deeper than what this thing actually sticks up. And so this part here goes down into the mantle of the earth. Okay, the second one says that less dense regions are going to be higher. Okay, so for this one, if you can go to a hardware store and get 2 pieces of wood, so maybe you might want to get like balsa wood and then oak, and you want to make sure that the 2 pieces of wood are identical in shape, so that they'd have the same height, same width, same length, but they're made of 2 different kinds of wood. And then put them into the water, and you would notice that like the balsa wood would stick up higher out of the water than what the oak would, because oak is a more dense material than what the balsa wood is. Now, can you think of 2 rocks that are of different densities? One's found in the ocean and one is found on the continents. What would it be? So continents are primarily made of granite, and then the oceans are made primarily out of basalt. Basalt is more dense rock than what granite is. So that's why the continents stick up out of the ground, and then the oceans are under the water. So topographically speaking, the oceans are lower than what the continents are. Okay, then the third one is that hot regions are going to be higher. So where you've got material, hot material coming up, it's going to cause the ground to go up as a result of it. And then the last one is really, that was the one that you were probably thinking of, compression. So whenever you compress a material and it wrinkles, then that means that it goes up. The wrinkles go up as a result of compression. All right, let's take a break, and when we come back, let's talk about what causes domes and basins.